Okay, guys. So this is just a quick video to kind of show you what we did on Wednesday while you were gone. Thursday, we're going to be going over that test, and those grades are in Power School. So let me know what you think about those. I think both of you did very, very well. So just a matter of time. If you would like to try to raise that grade, you certainly can, and doing a retake at some point. But I think you're both in pretty good shape for this one. Also, make sure you've watched the videos from your 2 days off on Monday and Tuesday if you haven't already. We will be talking about those a little bit today in class. So if you have some questions, shoot me an email, or we can schedule a time that you could Zoom in. Maybe we can meet during one of my open hours, maybe fourth hour or something like that too, if you're up for that. And then tomorrow on Friday, we'll be taking that quiz, and the rest of the class will have some time to do some makeup work and stuff. So you're not missing a whole lot this week, and then next week I think you're back on Thursday or something like that. So I think we're not missing too much here. That's good. So yesterday in class on Wednesday, we talked about visual reasoning, and the whole idea with visual reasoning is that a lot of times a problem like this seems really, really complicated. There's a lot going on. It's easy to make some misconceptions about it, or think of the problems just in a slight way that's not quite the way it actually is, and that causes a lot of problems or issues with trying to get the answer right. So on something like this, general word problem or general problem solving strategies apply still, but the math in something like this is not the challenge here. So we've got volumes 1 and 2 of a 2-volume set of math books. So we'll think about what that looks like. They sit in their proper order. Volume 1's on the left and volume 2's on the right on a bookshelf. So if you can imagine 2 books sitting on a bookshelf, book 1's to the left, book 2's to the right, because that's usually the way they stand. Each front and back cover is 1/8 of an inch thick. So I think we would know that that's pretty important. And the pages portion of each book is 1 inch thick. So that's telling you how thick the covers are and how thick all the pages of book 1 together are 1 inch thick. All the pages of book 2 together are 1 inch thick. And so we've got a bookworm that's going to eat through this book. Starts at the first page of volume 1 and burrows all the way through to the last page of volume 2. And we're supposed to answer how far will it travel. Now, the math that's going to be involved in this is something you've known how to do since about 4th grade. It's just adding. There's that fraction in there, but it's not like you have to get common denominators or anything. So seems like it'd be pretty easy, but then you start to think about this and you're like, what exactly is going on in this problem? Without a picture, it's really hard to visualize what you're thinking about. So a lot of times I'll see students starting off kind of like this. They'll be drawing the books and they'll say, okay, so this is my cover. There's a cover, there's a cover, there's a cover. And then all in the middle here, we've got pages. All right, and that seems like a pretty reasonable representation of this problem. And so they go, okay, the first page of the volume 1 is right there, and the last page of volume 2 is right there. So that would make it, what, 1 inch, there's 1/8, there's 1/8, and there's another inch. And that's usually what most people put. That adds up to 2 1/4 inches. Oops, not 2 1/2, 2 1/4. But that's not what the problem looks like. The big thing here is, do books sit on a shelf like this with the pages facing out? And they absolutely don't. They usually have the backs to you. And so a different way to draw this that might help out a little bit more is going to help think about what's going on here, because that's not how books sit on a shelf. So I'm going to draw these as like top-down view. So there's 1 book, there's 2 books. I've got my pages in the middle, and those are like the top of the books. So here's the person standing in the library, and these books are on a shelf. So this one's volume 1, this one's volume 2. Now the question is, where is the first page of volume 1? If you actually think about this as a book from the top down, the first page of volume 1, the cover of volume 1, is this one right here. This is the cover of volume 1. Right there. And so the worm actually starts right here. And it actually ends on the last page of volume 2. The last page of volume 2 is not here. Sorry, my mouse is not working well. It's not here, it's actually right here. So that's where the worm ends up, is right there. And so it actually doesn't go through any of the pages. It just goes through this cover and then this cover, and it's already where it wants. So an eighth and an eighth makes 1/4. And that ends up being the actual answer. So not that that answer was hard to do mathematically by any means, but you've got to make sure you're actually understanding the problem the way it is in real life. It's not trying to be tricky. It's just that when you don't think about it, or if you don't draw the picture out correctly, it's easy to get a misunderstanding of how that problem works. So with this visual reasoning stuff, the main goal here is this first one, translating a description into a diagram or vice versa. That diagram could be a picture like we just drew. It could be a Venn diagram. It could be a graph. It could be a chart. Most of these are going to be drawings, though, drawings of the situation that we're trying to solve. So one of the words we talked about here was locus of points. This is all the points that could be a solution to a problem. Usually what this is happening with is a problem where there's more than one solution, or in fact, there's actually infinitely many solutions, because a lot of times problems don't just have one solution. They have lots of solutions that you could choose from. And so it's usually helpful to draw them out. Something like a line like you graphed last year in algebra was a locus of points. Those points on that line represented the solutions to the equation that you graphed. So simple one here, we've got something like Jim is standing in equal distance between two parallel roads. If we have our two parallel roads, and this is really one where you really have to draw these, there's no way around that. So there's a road, and we start thinking about, well, where could Jim be? Well, Jim could be there, Jim could be there, Jim could be there. You know, all of these points are an equal distance between the two roads. There's no way to say exactly which one Jim is at, but what we can do is we can say, well, Jim is somewhere along that line, right? That line that goes right through the middle of the two roads. Jim has to be somewhere along there. So that's going to be our answer, right? We know that Jim is going to be somewhere along. I cannot draw an arrow with my mouse, sorry. That line there, that represents all the places he could be. Okay, so last one I want you to do, and I actually want you to try this one. So pause the video here, read through the problem, and then unpause it, and then I'll talk about it for you. Okay, I actually paused in real life, so give you a chance to actually pause it. Hopefully you chose to do that. So we've got Harold, Dina, and Linda. They're on a flat field. They're looking for treasure. So Harold is standing at one of the features on the map. He's a gnarled tree stump. Dina is standing on a large black boulder. The map shows the treasure buried 60 meters from the tree stump and 40 meters from the boulder. And currently Harold and Dina are 80 meters apart. And we want to know, well, where's the treasure? So when you're drawing something like this, just start by including everything you can think of. So I'm going to let my paper just represent that flat, dry field. There's got to be a tree stump over here somewhere. There's a boulder somewhere over here. And a good strategy on all of these problems is to just mark how far apart are they. So they are 80 meters apart right now. Now, the next thing it says is that the treasure is buried 60 meters from the tree stump. So at that point, if all we know is that it's 60 meters from the tree stump, it could be, right about there, but it doesn't have to be. It could also be 60 meters, up here, or 60 meters away over here, or 60 meters away down here. Actually, that look of where all the points could be actually makes a circle, and it goes all the way around this tree stump. Right? That's not a very good circle, but just imagine, it wouldn't fit on my paper, but anywhere 60 meters away from that tree stump in any direction could be that treasure. But since we also have that other information that it's 40 meters from the boulder, well, 40 meters from the boulder would be like there, or there, or there, or there, or there. It's making a circle too. And so now we want to look at the points that are both 40 meters from the boulder and 60 meters from the tree stump. A point like in here isn't 40 meters from the boulder, it's less than that, but we've got a couple of points that are exactly 40 meters from one and 60 meters from the other, and that's where those two intersect. And so those 2 points are our locus of points for the problem. These 2 circles are the locus of points for each of the individual parts, right? The green represented all the points 60 meters from the tree stump, and then the blue represented all the 0.60 meters from the boulder. So that's kind of the idea behind visual reasoning. If you would have been in class, we definitely spent some time where we talked about these and asked questions and thought of ideas. So all those normal problem solving strategies that you have, keep using those too. But the idea we talked about yesterday for sure was draw the picture. Even if you're not exactly sure what it looks like, just start by drawing what you know for sure. And that's going to help you get more information about what's actually going on. Okay, I will see you hopefully I see you in person next week, right?